All right, my chemistry class, welcome back to another edition of chemistry, obviously. And today we're going to be talking about units of measurement. Talk about the metric system. We'll also be talking about temperature and how all this plays out. Uh, this should be kind of quick. Again, hopefully going through the notes, it shouldn't be too bad. We'll try to review this in class. But when we talk about units of measurement, there are two different ones. So there's the English version. This was developed for common use. So you might be familiar, like, inches, feet. Um, those are just a few examples. Cups, ounces, quartz, like all that different stuff is English. So it's really cool if you're English because you understand what's going on. Like if I were to say like, oh, that person is 6 feet tall, you would understand how tall the person is. But if somebody was living in Germany, if somebody was living in China, they might not have an idea what you're talking about because they deal with the metric system. And so that's kind of a big fault, especially in the science community when we can't really use the English system for measurement because it does lack that uniformity, lacks coherency, and it's not the easiest to use because you're dealing with a lot of different numbers. Like there's 12 inches in a foot. Um, Talking about, there's 12 or not 12, there's 3 feet in a yard. So there's a lot of different ways I go into it, and it's kind of complicated, a lot of different numbers. But in the science community, we like to use the metric system. And so this was developed in France in 1795. And this is really simple base units. And it uses a lot of interchangeable prefixes, which help with different measurements. And the best thing about this is it's in a base 10 system. So 10 meters, 20 centimeters, right? It's easy to convert from one unit to another. It's easy to convert uh, the interchangeable prefixes. And so we're going to go over that today and how that looks. And so when we look at the metric prefixes, you might be familiar with a lot of these symbols, right? And it goes from kilo, hecto, deca, deci, centi, milli. And you're going to be familiar with a lot of symbols, right? So kilometers you probably have heard of, millimeters, centimeters when we're using rulers, right? So you probably have a decent idea of what each one is. And so when we talk about a kilometer, we are looking at 1,000 of that base unit, right? So again, when we talk about a meter, think of it as like the base, as like the norm, as the center. And so when we talk about a kilo of something, it's going to be 1,000 of that. So for example, 1 kilometer is 1,000 meters. 1 kiloliter is 1,000 liters, right? So just think of it that way. Hecto, symbols in H, that just deals with 100. So that can be seen as HM. Deca, DA, is just 10. And then we get into the smaller prefixes. So a decimeter is just 1/10 of a meter. So just 1 divided by 10. Centimeter, right, is 1/100th. So 1 divided by 100. And then millimeter is 1/1000th, right? We could go deeper and, we could go into micros and all that, but only for this time, we're going to worry about just those six. Well, technically seven with the base, but those six prefixes there. And then, again, this will help out. Also, another way to think about it. So when you think of a liter, just think of liquids. So half of a 2 liter pop or soda. So like a 2 liter bottle of Mountain Dew. Essentially, a liter is just half of that. When you think about a meter, just think about a yardstick, inches longer than a yardstick. So a meter is longer than an inch, but when you think of a yard, think of it as essentially a yardstick, a meter stick, um, probably half the size of your body or half the height. When we talk about a decimeter, we talk about the width of the hand. So essentially, think about the left side of your hand to the right side of your hand, from the pinky side all the way to the index finger. That width, that would be about a decimeter. Centimeter is going to be the thickness of a notebook. Millimeter is going to be the thickness of a CD. When we talk about a kilometer, that's more than half a mile, so about 0.6. And then a gram would be about the size of a paper clip. Using SI units. So we're going to go through the different SI units, and again, it's going to make sense when we're talking about different things. So we talk first about units of volume. And when we talk about volume, we're talking usually about liquids. We can talk about gases and all that, but again, we are giving the size of something, not the weight, well, not the mass technically, but when we talk about volume, we talk about how much there is on a 3D scale, right? So these figures might have a good idea. So like a millimeter or milliliter is going to be a droplet from a pipette, possibly from an eyedropper. But we talk about a liter, and again, that's going to be like half a liter or half a 2-liter bottle, maybe like a bigger bottle than a water bottle. And so these are a nice size comparison. But again, when we're talking about volume, we're talking about how much of it there is. Just a little history when we talk about the units of measurement in history. The SI, so the International System of Units, developed by scientists in 1960. There are 7 fundamental units, derived units based on fundamental units. And again, volume is going to be one of them. So if we look at the SI fundamental units, we look at length, mass, time, temperature, amount of substance. Looks like we are possibly missing some. Yeah, possibly. But these fundamental units are going to be seen in everything. So when we talk about length, we're talking about meters, so how long something is. When we talk about mass, again, that's going to be measured in kilograms or grams. Time is going to be in seconds. Temperature, Kelvin. An amount of substance, again, mole. We're going to go into mole later into the semester, so don't worry about that right now. But again, when we do amount of substance, a mole. And so from those SI units, we can derive a lot of different units from it. So we talk about area. Area is going to be a unit in square meters, so m squared or meter squared. And essentially what an area is going to be length times width. So meters times meters, that would be the unit. Volume would be in cubic meters, so length times width times height. So it's going to be meters times meters times meter. So m cubed. Density, so how dense something is going to be kilogram per cubic meter. So we do kilograms divided by meters cubed, or meters to the third. And so that's essentially going to be mass divided by volume. And in the units, it's going to be kg divided by m cubed. Velocity, or how fast something is going, is going to be meters per second, ms. So that's going to be derived from length divided by time, m over s. Force, the unit for force is going to be newtons. And so the symbol for that is going to be N. How to derive that would be mass times length divided by time squared. And so in the units, it's going to be kg times N divided by S squared. Now, again, when we're talking about these units, whenever you are doing some type of calculation, you have to say what unit it is in. Because if I'm like, oh, it's 32. Well, 32 what? 32 grams, 32 kilograms, or 32 meters. Like, you got to be specific in what you're talking about. Pressure, when we talk about pressure, we talk about pascals. So PA would be force. So again, force divided by area. So N is equal to kg times M. But again, when you talk about units, it would be N over mg is equal to kg over m times s squared. And again, that deals with algebra and equaling that out that way. And then energy, we measure energy in joules, and so that's going to be force times length. So N times M, which is equal to kilograms times uh, M squared over S squared. Again, that kind of got messed up there, but it is what it is. We move on to temperature, and temperature is the type of energy transferred because of a difference in temperature. This cannot be measured directly, but temperature is going to measure the average kinetic energy of the particles in a sample of matter. So it's going to determine the direction of heat transferred. Heat moves from object of high temperature, or heat will move from a high temperature to object at low temperature. So again, high to low, we kind of saw that with the fusion in your probably biology class. So again, high to low, heat's going to move from high to low. You guys might be familiar with this when we talk about Fahrenheit. Fahrenheit is the zero values based on equal mix of snow and ammonium chloride. So 32 degrees Fahrenheit is freezing point of water, while 212 degrees Fahrenheit is going to be the boiling point. Celsius is going to be based on water. So 0 degrees Celsius is going to equal the freezing point of water, while 100 degrees Celsius is going to be the boiling point of water. And then finally, we got Kelvin. Kelvin is the only temperature scale that is proportional to the speed of particles. So 0 degrees Kelvin, all particle motion stops, so absolute zero. At this point, it's cold. It is freezing cold. 273.15 Kelvin is the freezing point of water, and then 373.15 Kelvin is the boiling point of water. Just looking at temperature scales and how that looks, the figure below compares the Celsius and Kelvin scales. So the 0 point on the Kelvin scale, 0, is equivalent to negative 273.15 degrees Celsius. Okay. So again, different ways of measuring it. There are conversions to get to each one. We'll talk about that. But you have to be specific when you're talking about what you're measuring in. You're going to look at the thermometers that we use in class eventually, and you're going to see that it's going to be measured in either Celsius or Fahrenheit. So you got to be very smart about the observations you make, and you got to be very clear about what units you are using. And then to do conversions, right? So if you wanted to do the temperature of Kelvin, that is equal to the temperature of Celsius plus 273.15. And again, if you wanted to find Celsius, you would do the temperature of Kelvin minus 273.15. So again, it's easy that way, basic algebra. And then Fahrenheit, I'm surprised she doesn't have Fahrenheit on here. I can find that if time needs be, but again, these are the only conversions you will need to worry about right now. I believe when it comes to Fahrenheit, I think it's Kelvin times like 9/5 maybe. Again, I have to check. I'm not exactly sure what it is, but I will get back to you on that when the time comes. But this is all you really need to know for temperature and the metric system.